everyone, my name is Sze Wen, and together with my group member Jian Quan, in this video we are going to present our assignment for the subject Fundamentals of Computer Network with the subject code AACS2034. In this assignment, the two of us has been hired as network engineers of middleware broadcasters. Our objective is to design and set up a local area network for the organization based on the given scenario. In the given scenario, there has three locations, which is location A, location B, and location C. The distance between location A and B is 500 meters, while the distance between location A and C is 200 meters. Each location houses various departments in different floors. Now, looking at the table display, we can see the number of hosts required for each department. Notice that we were also required to consider the number of addresses needed for 20% growth in all areas. So, the last column shows that the recalculation of hosts after 20% growth. And we can see that administration department requiring the largest host, which is 604 hosts. Given that each switch can accommodate 24 ports for connecting end devices, we can estimate that approximately 26 switches will be needed to fully support the connectivity requirements of one department. Here is the formula to calculate the number of switches needed of one department. Now, let's look into the network topology we have designed. We have three main locations, which is location A, B, and C. We use a pink ellipse for location A, a light pink ellipse for location B, and a light green ellipse for location C. Within each location, we have multiple floors, which are represented by squares. In our network topology, we have opted for a simplified representation to enhance readability and reduce complexity. Instead of individually describing the estimated number of switches needed for one department, we are using one switch symbol to represent the total number of switches required. For example, here is the topology of location A. In a complete topology, there are up to 26 switches are required, each with the capability to connect to 24 end devices, and one of the switches connects to the router. And here are the three departments within location B, and last, the department within location C. One of the intermediary devices that we have used in this assignment is router. We're using router MT and assign 4 fiber optic ports and 3 gigabit Ethernet ports on it to connect all the 7 departments network together. Since the router is placed within location A, we have allocated 4 fiber optic ports specifically to support connections between the router and switches at locations B and C, to ensure data transmission across all locations. Next, for the switch in location A, we're using switch model 24TT, which can support up to 24 ports. Due to the close distance within location A, we have used strip-through cables as connectors to link devices to this switch, ensuring efficient data transfer within the same location. And next, for the switch in location B and C, we opted for an empty switch to equip fiber optic ports that enable us to transfer data between location A to location B and C. Following the question, the IP address that has been selected is 10.0.0.0/8, which is a Class A IP address. And the subnetting techniques used was classful, which means that all networks will have the same number of IP address, and also ensure that all networks will have the same CIDR, which is prefix and subnet mask. And the subnetting was done based on the number of hosts required by each department. Since the largest number of hosts required is 602, the minimum of 10 bits had to be reserved for the host portion of the network address. This means that they will have 1024 IP address within the network. However, we must exclude 2 addresses, one for the network address and one for the broadcast address. So the number of usable IP address will be 1022. And here showing the subnetting table we have done for this assignment. Next, we will pass to Jian Quan to finish his part. Thanks.
Hello everyone, I'm Jian Quan, and I will continue with our addressing table. Let's start with the router 1, which does not belong to any department. It has 7 interfaces, gigabit Internet 0/0 through the 0/6. All with the same subnet mask of 255.255.252.0. For gigabit Internet 0/0, we have assigned the IP address 10.0.0.1. representing the first subnet and its first usable address. Similarly, gigabit Ethernet 0/1 has been assigned 10.0.4.1, representing the second subnet and its first usable address. We can repeat this process for the remaining gigabit Ethernet interface. Next, moving to the location A, we have 3 departments: administration, newsroom, and production. The administration department has administration switch 1 with interface VLAN 1 using the subnet mask 255.255.252.0. We assign the valid IP address 10.0.0.2 to it, with the default gateway set as 10.0.0.1. For the end device, we have PC0, PC1, and PC2. All have the same NIC interface and subnet mask. Each of them is assigned a valid IP address within the range, starting from the 10.0.0.3 and incrementing by 1. Same as the location B and location C, doing the same step, we can refer to the subnetting table to ensure that we have assigned the correct IP address. Next, let's summarize the device in our network topology. In location A, we have 1 intermediary device, which is the router. Each department is equipped with 1 switch and 3 PC. We can total up them, so we can get the total of device, which is 29. Next, move to the network configuration. For network configuration, we need to change the host name. For the change the host name, we need to enter enable configure T and enter host name administration underscore switch 1. So as you can see, the name is already changed. So for set up the password, we need to go to configure T and enter line console 0 and password CLA33. After that, enter login. So for the second password, we need to go to configure T and enter enable password CLA33. So for the secret password, we need to go to configure T and enter enable secret AACS2034. So after set up the password, we need to set up the interface. So we can go to interface VLAN 1. After that, we enter the valid IP address and its subnet mask. After that, we enter node shutdown. After all the steps is done, we need to enter copy running startup to save the data. After we set up all the switch, we need to set up our router 1. So for the router 1, we also need to change the host name and set up the password. After that, we need to set up our interface gigabit. So for example, we can enter interface gigabit 2/0. After enter to it, we can enter the IP address and subnet mask. After that, enter node shutdown. So for the remaining gigabit internet, it can just repeat the step same like gigabit internet 2/0 for their own IP address and subnet mask. Next, we move to ping connectivity. So for this part, we have an example PC0 ping to PC18. So for this example, we need to open PC0 and its command prompt. After that, we enter ping 10.0.24.3, which is the IP address of the PC18. For the first time ping, you may see the result request timeout and the 25% loss. It may caused by the potential delay. So we need to ping second time. For the second time, you may see the result is packet sent equal to 4, receive equal to 4, loss equal to 0. So it means that this ping is successfully. That's all from me. Thank you for watching.